Hi everybody, Chris Biddle from Light23 here. What I want to show you in this video is how to connect a NodeMCU microcontroller, which is basically a breakout board for the ESP8266 chip, and how to use that to drive a matrix of LEDs, which is in this case, an 8 by 16 matrix of LEDs, and how you can control it through a Wi-Fi connection from your smartphone. So in this case I have basically the microcontroller, the NodeMCU, serving up a web page that I'm connecting to through a Wi-Fi connection, and using that to control these LEDs. So basically I have 5 animation patterns here. Right now it's cycling through all the patterns, but I can say select like shuffle back and forth, and then it's just the line going back and forth, and I can go one at a time. And then it's the line scrolling forward one at a time. I can do this multi-panel train, which sort of shows a block of colors moving through. The fading trails is similar to this multi-panel train, except it's sort of a gradient, so that it trails off. The light kind of gets dimmer and dimmer towards the end there. And then I have the rainbow pattern, which displays a propagating rainbow. So these are relatively simple patterns, but the idea is once I show you the code, you'll be able to program your own patterns and animations in there. There's also a feature in here that where I can adjust the brightness. So right now I think it's on low. I can change it to medium and it'll be much brighter, and on high at the full brightness. So there's 3 brightness adjustments, and also a run mode where you can turn it on or off. So if I hit the off link, it will turn it off, and then I can turn it back on. Basically the run mode here doesn't actually cut off the power to the NodeMCU. It just basically puts it into a standby mode. Anyway, that's the feature that I have controlling the LEDs, and like I said, I will show you the code and kind of walk through it, and so you'll be able to make your own animations that hopefully are a little more interesting than the ones I have programmed in here. Anyway, let me start into the hardware here, since I've talked a little bit about what it's doing here. The hardware connection is relatively simple. I have a 5-volt power source, a DC power source, running into the end of this breadboard. So 5 volts in here, and this is the ground. And so the 5 volts I'm supplying to the VIN on the NodeMCU. So there's a VIN pin on the NodeMCU here, and then the ground is going to the GND pin, which is right next to the VIN pin over here. Then I have a data line on pin number D8. That's D8 running from the NodeMCU over to a 220 ohm resistor, and from the resistor to the LED input pin, the data input, which is the middle pin on this matrix. The ground is going to the ground on the LED, and then the power source, you want to also have 5 volts running into the LED. A real important thing about this circuitry is that you want to make sure that the ground on the NodeMCU and on the LED matrix is on the same plane, that they're all grounded on the same plane. If you had this ground connection going somewhere else to a different ground, you're going to get some unpredictable results with the matrix. It's going to flicker and do some crazy things. So make sure that both your NodeMCU and your LED matrix are on the same plane. So again, very simple connection. Basically you have 3 connections from the NodeMCU, the 5 volt voltage supply, and the ground, and then the data line coming from D8 into the LED. the data on the LED, and and you have to have a 220 ohm resistor on that data line to make sure that you're not overloading the LED. The LED matrix is made up of WS2812B LEDs, and that's a common LED strip. It usually comes as a long strip, but in this case it's shaped into a 8 by 16 matrix. So that's about it as far as the wiring, and so now I will get into the code. Okay, so here is the body of code that's going to be uploaded into the NodeMCU. I've opened it up in the Arduino IDE. I have version 1.8.9. It's probably not the latest version of Arduino, but it's certainly late enough to have all the features that I need. So a couple of prerequisites before we can compile and upload this code. You'll need access to a couple of libraries. The ESP Async Web Server library. This web server library has the APIs that you need in order to enable this the NodeMCU as a web server. And then you'll also need access to the Arduino Fast LED libraries. So that can be accessed through this URL. So both the libraries, I've specified the URLs which you can access to get to them. So once you download the libraries, what you do is or download the zip files. You would unzip them to the library folder where your basic sketch folder is. So to know where your libraries would reside, you go File, Preferences, and then your sketchbook location. You should have specified a particular location for your sketches. So in my case, it's this path here, C, CK-bit documents, Arduino. So in there, in my documents folder, I have Arduino, and within there I have a libraries folder. And this is where I have my my Fast LED library and my Async Web Server libraries, which I downloaded from the sources specified in the code. So once you download those libraries and put them in the folder that matches up with your sketch, you will also need to have access to the NodeMCU or compatible board. In other words, you'll have to go into your boards manager, and through your boards manager you can type ESP8266, and then you'll find the package that you need to download and install in order to make sure your board is accessible. In my case, I use the NodeMCU 1.0 ESP12E module, so you can see that I have that already installed. So since I already have it installed, it's specifying install, or it's specifying that it's installed. If it's not installed, you'll have an option here in order to install it. So once you do that, you will be able to go sketch, board, and your list of available boards would be available down here. And in my case, I have the NodeMCU 1.0 ESP12E module. If you wanted to, if you had another body of code that you wanted to upload into, you know, say just the Arduino Uno or something, you would specify that to be your board. So anyway, those are the prerequisites before we that you would need to have set up before we start to get into the code. All right. Okay, so let's start by just taking a look at some of the I guess you'd call them preprocessor directives, these pound defines and some of the includes.
obviously, since we included these libraries, in order for the code to be accessible or usable, you need to include the header files that come with the libraries. So here are the two header files. And then this little directive here is needed in order to be able to specify the input pin for the fast LED APIs to be this D8, which is the LED pin on the NodeMCU. So without this little directive here, it wouldn't recognize this D8. So you do need that in there. And of course, before I go on, let me just say, if I get too much into the weeds with some of this code that I'm explaining to you, don't worry too much about it. I'm just basically going to explain the code, maybe go in depth in some areas, and maybe high level in some other areas, but it's not like you have to understand everything about this code in order to be able to compile and run this. Obviously, it's going to run once you compile and upload it, and then and so you'll be able to just kind of walk through and figure out the code yourself. I just want to be able to explain some of the features, so if you get stuck on something, you don't understand something, you can watch this video and sort of get a better idea of how to go in and troubleshoot it or make enhancements. So that's kind of the idea behind my explanation for all this code. Having said that, let's continue. There are 128 LEDs in the matrix, since it's 8 by 8, two 8 by 8s, so that's 64 plus 64. So that's what I have specified here. Your LED type, they are WS2812Bs. In the color order GRB, green, red, blue. This default frame rate, 40 frames per second. And the default brightness, well, 255 is the maximum brightness you can have for the fast LED library. So a lot of these directives here get passed into the initialization for the fast LED library. So you'll see them getting passed into the fast LED APIs. These values here are just values that I'm specifying for the various patterns. So I'm not actually passing the numbers themselves into the code. I have them named so that you can easily identify what the patterns are. So that's what this is about. This is the array that the Arduino, the fast LED library, uses to access the LEDs. So you'll see this array being passed into the initialization APIs for the Arduino. I mean, for the fast LED. And then you have your this rainbow palette is basically the set of colors that I'm using to specify that rainbow pattern. So this is the red level, and then green and blue. So starting out as red and then going into a little more green, and green is increasing, and then we have more blue we start to add in, and the red starts to fade out. So this is the color scheme for that rainbow pattern. And I have various other arrays that I'm using to pass into the code to have the algorithm work. So that's what this is all about. This gradient array is another, it's a set of values that I'm using to specify the brightness for that gradient effect, that one trailing pattern that I showed when I was describing the hardware. So that's what that is. A lot of these are just global variables that I'm accessing from the functions. So I don't know if there's anything really, wouldn't be sort of self-explanatory in the code. So I'm just initializing a lot of global variables here. This is fairly important in that when I'm using the NodeMCU, setting it up as a Wi-Fi server, I'm using the access point mode as opposed to the server mode. So with the access point mode, that means you can connect to it directly instead of going through your router at your home. And so with that access point mode, you need to set up your network credentials. So in my case, I have in order to be able to connect my phone to Wi-Fi connect to the NodeMCU, this will specify what the name of your connection will be when you're looking at your connections on your phone. So I would look for EL1601 Nightlight, and then the password, you can specify whatever password for the connection. So that's what these two values are, the SSID and password. The IP address is usually 192.168.4.1. So once you make that connection and then you want to get to whatever this page is that's going to get served up, you would access it using this IP address, 192.168.4.1. And then this async web server, this server object is basically the handle for getting to all the web server APIs. String, this string main page, this is the whole HTML code that's going to get served up to the phone. I have it contained in the code so that when you just access the URL, this 192.168.4.1, in other words, http://192.168.4.1. Once you get to that URL, this is the HTML that's going to be served up, and contains the links and everything you need. Okay, so now that I've talked a bit about the various global variables and the values that I'm initializing them with, let me talk about the setup routine. For all of you who might be familiar with programming in Arduino, the setup routine is the function that runs once in the beginning when the microcontroller is powered up. And of course, after setup, then you have loop, which is the function that runs repeatedly. And you would put the code in here that responds to various input actions. So setup runs once at the beginning, and then loop runs repeatedly afterwards. So in setup, you do a lot of your server initialization and that sort of thing. So here I'm opening up the serial port or serial communication at a baud rate of 115,200, so that if you use your serial monitor to view these print statements, you want to make sure that you have your baud rate set to match that. It doesn't have to be 115,200. You can make it 9,600 or whatever. Just make sure that your serial monitor output matches whatever you specify here. Now, this is the critical part that starts the server, so the web server. So you make this call, Wi-Fi.soft API, and I'm passing in the Wi-Fi connection name, SSID, and then the password. So these two values come from that global variable up here, the SSID and password here. So those two strings. Once the server starts up, I can get the IP address using this routine, and I'm just grabbing the IP address here so that I can print it out on the serial monitor if you wanted to see it. After that, what I have here are the various, I guess you can call them callback functions, basically registering the routine that gets called when the HTTP server gets the request from the client. So these values here match up with whatever you've specified in your URL for the links that get clicked. So when when for example the user clicks on cycle all patterns, that's just an anchor link that's going to call just the IP address, the root of the application, if you will. And so when they click on cycle all patterns, that's this callback routines that's going to get called, and then it assigns the pattern mode the value cycle, and then it sends a 200 OK response back to the client. So that's what this is. Same thing with here, like single panel. If the user clicks on shuffle back and forth, then there's this value that's attached to the URL, the root URL, and so it reads that single panel and sees that it matches up with this callback function, and then it'll assign the pattern mode of single panel back and forth, and this global variable here, and that will have the animation. It'll start to display the corresponding animation, and you'll see how it does that in the loop routine. So it'll assign a single panel back and forth to the pattern mode, and then this one, you can sort of see the pattern. For every one of these URLs that get called by clicking on one of these links, it will call the matching callback function that's registered here. So that's what a lot of this is. Here you have, for example, if the user clicks on the low link to set the brightness to low, this is the URL that gets called. So with the BR low there, and BR low will set the brightness to 10 and set the current brightness global variable to 10, and then just respond with a 200 OK back to the client. So that's the pattern here, and that's why we're doing all this. And then here you're actually starting up the server. Now here you are initializing the LEDs themselves. So you're specifying what type of LED here, the WS2812B, and then the pin number, the D8 that's being passed in, the color order, which I believe was GRB. So all these values are coming from the directives that we specified up here. So the number of LEDs, LED type, color order. So I'm passing that in down here, and then that the array of LEDs and the number of LEDs are all being specified. So, and then so this is where I'm actually specifying, initializing the LED strip, basically. Alright, so now that I've talked about the setup function, let's get a little more into the loop function. Now the loop function, as I mentioned earlier, is something that just is repeated over and over. So starting at the top of the loop, once it completes, it goes right back to the beginning and just keeps cycling through. So the loop function here is pretty extensive, and I probably don't need to get into every detail because a lot of the it's kind of a repetitive pattern. So if I just explain the first few lines, I think you can sort of follow through with the rest of it and understand the algorithm. So I'm not going to go through every single line of code. It's just not necessary. But anyway, at the beginning here, what I'm doing is checking that standby off variable. That standby off is just a Boolean that we're setting when the user clicks on either the on or off link on the interface. And for example, if they click on, then that standby off variable would be set to false. And as standby off is set to false, then as it's looping through, this variable is going to be false, so the not standby off will be set to true, and that means that it will call fastled.show, which means display the lights basically. And if standby off is true, that means this whole thing is false, and it will the LEDs will not be displayed. And then what I do is I'm continuously checking to see if the standby off variable is set, and which means that the LEDs are going to be on, or should be on, and if the pattern mode is equal to cycle. This pattern mode, as you know, gets set when the user clicks on one of the links, and you can see the variable gets assigned based on whatever link the user clicks, and it calls one of these functions and it changes the pattern mode. So as it's cycling through in the loop, we're checking here to see if the pattern mode is equal to cycle. Now if pattern mode is cycle, that means this is the logic. You're calling all this logic to cycle through all the different animation patterns. So the first thing I'm doing is doing the cycle by single panel, and this function call here is the routine that moves the animation forward from front to back, and then this one moves it from back to front. So it's this is like one sweep. This really indicates one sweep of red back and forth, and then it'll do one sweep of yellow back and forth. And when I say cycle by single panel, I mean basically just the one line that's going back and forth. So that's this whole routine here. And then I start iterating through and calling cycle by single panel with it set to true in both parameters, and that means that the line is sweeping forward in 2 strokes for each color. So it's sweeping forward in red 2 times, and then sweeping forward in yellow 2 times, green 2 times, and so forth. Now the reason I have these if statements that are constantly checking to see if the pattern mode is in cycle is because we know that the user, while the pattern mode is in cycle, the user could click on something else, on another option, like they want to do you know, like the rainbow or something. If they click on rainbow or something, then it changes. And we don't want to stay in the cycle pattern. Once the user clicks on rainbow, we don't want to stay in the cycle pattern. So we want to continue to check the cycle, the pattern mode, to constantly check it before going on in this routine, so it doesn't just stay locked in this routine till it goes all the way through and finishes before going into rainbow. I hope that makes sense, and I'm just trying to explain why I'm repeatedly checking for the variable. It's so that if the user clicks a different option, it doesn't just stay locked in this whole routine, that we're continuously checking it so that we know if it's not in that routine, not to execute it, but to exit the routine and go on to whatever other selection was made. So let's say, you know, we're running through here, the pattern mode is in cycle, and we're going through this code, and the user does click rainbow. All right. So what that means, it's going to trigger this callback here, and then the pattern mode is going to be set to rainbow, and then it's going to exit this cycle routine and check and execute let's see, standby off, pattern mode is equal to rainbow. So it's going to execute this condition here because the pattern mode is going to be rainbow now. And then it's going to call this cycle rainbow routine. So the implementation for these routines here, cycle rainbow, cycle fill panel, cycle by single panel, all that implementation is after the loop function. You can see I've got cycle by single panel here, cycle fill panel, cycle gradient trail, cycle rainbow. So these are the routines that are called, and then these in turn will call these other subroutines, the more granular ones, like the lower level ones, like light up row, clear row, and that sort of thing. So you can follow through the code that way. So I hope that kind of explains the general algorithm of the loop function, and I hope it makes sense to you. I don't know that there's much more to explain in the loop function. As you can see, there isn't really any obscure variable assignments or anything like that happening. So just having explained what I just did, kind of at an algorithm level, I think pretty much summarizes how the loop function works. All right. I think that's pretty much it as far as explaining the code. In the next step, I'll explain how the code can get uploaded into the NodeMCU. Okay, so now assuming that we've made all our edits, we are ready to compile and upload the code into the NodeMCU. So the first thing you want to do before uploading the code, obviously, is to ensure that you have your USB connection made to your NodeMCU, and that the port is available. So once you've made that USB connection, you'll see under Tools, Port, that port should be that you've connected to should be available there and selected. So in my case, I plugged it into port number COM5. Also, you want to make sure that your board, the appropriate board, is selected. You might have it, I don't know, on your Arduino, on an Arduino Uno or something, but whatever it is connected to, make sure that it is connected to your the proper NodeMCU module. So those are the two things that you want to make sure of, and once you do that, you can go ahead and upload your code. So I'm just going to up this half of the window a little bit so that you can see the status messages, but uploading is just a matter of hitting this arrow. So it'll start out by compiling the sketch, and it takes a little bit. And then you'll see some text going by, some status messages, and then it'll go into this mode where it says uploading. And after it's done, it'll say done uploading. And there you go. So that is the final step, and you have your code uploaded in your NodeMCU ready to run. That pretty much completes this video. If you have any questions or just want to make a comment, don't feel free to do so, or do feel free to do so, I should say, and I'll try to respond the best I can. Alright, hope you enjoyed this video, and take care. Be sure to subscribe to my channel if you haven't yet, and thanks for watching.